Hey guys, welcome back to the continuation of electrolysis. We have started the concept of electrolysis in which I have taught it to you already that what is the definition of electrolysis, what is conduction, what is electrolyte, what is an insulator, for example. And we should know this thing that ionic compounds can conduct electricity in two states. One of the state is molten, whereas the other state is aqueous when water is added to it. And then we have discussed this thing as well, that covalently bonded structures cannot conduct electricity, and why they cannot conduct electricity due to unavailability of mobile electrons. Then we have discussed the next term, that is called as an electrolyte. It is specifically used for ionic compounds only. Guys, there is something which is conduction, something called as conduction through electrons, and that is happening in case of metals, alloys and graphite. So they are not considered as an electrolyte. So electrolyte term is specifically used for ionic compounds. Then I have taught you that what is an electrode, anode, cathode regarding the charges of the battery to which terminals they are attached. And then we have discussed about the inert and active electrodes depending upon the materials, and this is the whole thing which we have plan to discuss. So right now I'm going to discuss molten compounds electrolysis. Molten ionic compounds electrolysis. Molten state, it means that no water is added into it. Okay, water is not present. And compound is compound is just heated so that it may melt, and forces of attractions, electrostatic force of attractions, okay, forces of attractions between positively charged and negatively charged ions may break up. Okay, ions will be free to move, hence they can conduct electricity. Done. Okay, I'm going to give you an example of electrolysis on the next page. It is the electrolysis of molten sodium chloride. Electrolysis of molten sodium chloride, it means that it is just sodium chloride and we are heating it till the level it is melting, and it can have free ions. Okay, so what are the ions from sodium chloride? It is Na plus 1 and Cl1 minus. Na is a part of group number 1, hence it will acquire a charge of plus 1. Cl is a part of group number 7, hence it will acquire a charge of minus 1. Okay, Na is positive, so being positive, it will be attracted towards a negatively charged electrode. And what is the name of the negatively charged electrode? It is called as cathode. Okay, and at the cathode, what will happen? It is reduction, which is now going to occur at the cathode. And what is reduction? Reduction is gain of electron. Okay, and what about the Cl? It is being negative, it will be going towards the positively charged electrode. Okay, and what is the name of the positively charged electrode? That is called as anode. And at the anode, what is happening? Oxidation. And what is oxidation? It is oil or reg? Yes, it is oil. What is oil? Oil is loss of electron, means oxidation is loss of electron. Okay, loss of electron is happening here. Okay, guys, don't forget one thing which I am telling you since the beginning, that all the elements of group number 7, oxygen, nitrogen, and hydrogen, are naturally diatomic. It means that we are going to make Cl2, whereas all the metals and all the elements of group number 8 are considered as monoatomic. Okay, monoatomic means they are existing in the form of a single atom, whereas diatomic is a term when two atoms are combined together to give you that diatomic molecule. Okay, so here there is no molecule in case of metal. They are existing in case of they are existing as a single atom. Okay, so it is Na plus 1 electron converting itself into Na atom. Okay, now if you are writing for Cl, what will be the equation? It will be Cl1 minus arrow 1 electron plus Cl, as it is diatomic, so I have to write 2 Cl1 minus arrow 2 electrons plus Cl2. Okay, now the one which has gained the electrons in ionic bonding is now going to lose the electron, and the one which has lost the electron in ionic bonding, sodium has lost the electron in ionic bonding to make Na plus 1. Now in electrolysis, it is now going to gain that electron back to turn into the metal again. Okay. I'm going to describe you this thing on the next page as well so that this concept may be very clear. You can see this thing that two electrons are being lost. Those electrons which are written in the products are considered as the lost electrons, and those electrons which are written in the reactants are considered as gained electrons. So here I am writing this 2Na plus 1 so that I may be able to balance the number of electrons, and that is this. Okay. Then I can say that what is the resultant equation? We can see the number of electrons are equal, gain and lost are equal. So we can say it is 2Na plus 1 plus 2Cl1 minus arrow 2Na plus Cl2. Okay. So this is how we can say that we are forming sodium metal and chlorine gas. What will be the observation for this reaction? Sodium metal, you may say silver gray metal. Observation means you cannot tell the name of the metal, you have to say what you are observing. So silver gray color metal is deposited at cathode, and what about the anode? Yellow green color gas bubbles are observed at the anode. And when litmus solution will be added near the anode, or when litmus paper will be immersed near the anode, we can observe this thing that due to chlorine formation, the litmus paper, damp blue litmus paper, will change its color to red and then to white due to acidic and bleaching nature of chlorine, whereas the silver gray color metal will be observed at the cathode area. Okay, so these are the observations regarding the molten sodium chloride. Now I am telling it to you that in case of ionic bonding and what is happening in case of electrolysis, how ionic bonding and you may say electrolysis are opposite to each other. Ionic bonding, okay. So we have atoms in ionic bonding which are turning themselves into ions in ionic bonding, either by loss of electron or by gain of electron. So what is the starting point of ionic bonding? It is an atom. And what is the ending point of an ionic bonding? It is ions. Okay. And what about the electrolysis? In case of electrolysis, we can say that basically we have ions at the start and they are turning back into atoms. Now the point is this: the ones metallic partners have lost the electrons in ionic bonding, whereas in case of the electrolysis they are now going to gain the electrons. Non-metallic partners have gained the electrons in ionic bonding. So here in electrolysis, non-metallic partners are now going to lose the electrons. So we can say perfectly that ionic bonding and electrolysis are opposite to each other. Okay, so please carefully keep this point in your mind. I am going to solve one more example for the molten electrolysis, and that is, let's consider CaBr2. Okay, now what is the name of this compound? It is calcium bromide. Okay, calcium bromide. Now we know this thing that calcium is a part of group number 2, whereas bromine is a part of group number 7. Okay, so what type of ions will be formed? Ca2 plus, whereas 2Br1 minus. As there are two Brs in that, so we are going to take separately each of the bromide ion. Okay, where it is going? It is going towards the negatively charged electrode, and at the negatively charged electrode, what is the name? That is called as cathode. And we will say that reduction is happening over here. Okay, done. What about the bromide? It is going to the positively charged electrode, and that is called as anode. And here there will be oxidation. Okay, and oxidation is loss of electron, whereas reduction is gain of electron. Okay, then we can say that here Ca2 plus is going to gain how many electrons? 2 electron, converting itself into Ca metal, whereas 2Br1 minus, each of the bromide ion is going to lose 1 electron. Overall there will be loss of 2 electrons and then Br2. Okay, so what will be the resultant equation? The electrons gained and lost will be cancelled, and the final equation will be Ca2 plus. Ca2 plus or Ca plus 2 is the same thing, plus 2Br1 minus arrow Ca metal plus Br2. What will be the observation in this case? Red brown colored gas will be observed, red brown colored fumes will be observed at the anodic chamber, whereas at the anodic part, whereas a silver gray color metal will be deposited, will be observed at the cathode. So these are the observations regarding these molten compounds electrolysis. We are done with the basic concepts of the electrolysis in our previous lecture, and we have practiced the electrolysis of the molten compounds in today's lecture. Okay, so whenever there is molten compound, what you need to keep in your mind is that there is no water added into it. Okay, all the best to all of you. See you in the next class with the diluted solutions electrolysis. Okay, thank you, take care of your